My name is Carolyn Finch. I'm the program manager for the Digital Corridor. We're happy to have you. This is our, I don't know how many we've had now, I think our sixth code talk. And today we're discussing crafting quality code. Before we jump into that, I wanted to let you know today we just posted up a one-day boot camp in Code Camp. So if you've been inspired after today, and if you want to dive in more, we've got a code class for you. It'll be September 20th, a 6-hour one-day boot camp on crafting quality code, unit testing, command line tools, version control, and touching on some of the topics we're discussing here today. So with that said, I want to introduce the panelists. Chad will be getting into a little more of the details, but I wanted to thank our row up front here. We've got David Elam from PayNearMe, Sarah Simpson from Blackbaud, and Andrea Williams from People Matter. I wanted to thank them for coming and sharing their insights. I heard this is a heated topic, and I welcome a heated discussion. Chad Cravens will be moderating the topic today. But if at any point you have any heckling you want to do, or raise your hand and ask a question, we definitely welcome that. So with that said, I'll give it off to Chad, and we'll get started.
Oh, okay. Awesome. Good morning, everybody. Morning. So welcome very much to our Crafting Quality Code seminar. This is actually one of my favorite topics as well, because there's nothing better than good quality software, especially when you're deploying to production. So in order to be able to test your code during development is a big deal, and I feel that this is one of the areas of software that has really just exploded over the last 5 or 6 years. Concepts of continuous integration, automated testing, these dedicated teams of testers, and the tools that we now have available to us, open source tools, in order to automate these processes. Anything from front-end testing, end-to-end user testing you can automate, integration testing with other systems, and unit testing to actually test small specific parts of your code. So we're going to address all of those things today. We have a wonderful panel here that I'm going to go ahead and introduce. Like I said, here we have 4 different companies represented. People Matter, PayNearMe, which is a company out of California, Silicon Valley, and Blackbaud. And People Matter and Blackbaud are here in Charleston, and Open Source Systems is my company here at the Corridor. And we have Sarah Simpson from Blackbaud, and she's the Director of Quality Assurance, so she knows this stuff, which is good. And she, I guess, wants to talk about code quality, technical debt, which is an interesting topic we will definitely discuss today. Insisting on unit testing and code reviews. So during the development process, how important is it as a team? So really, there's a big difference when you're coding in a course like Code Camp, and you're coding by yourself, and you're trying to make your little program work, as compared to when now you have to start integrating as a team. The complexity of your build processes and your development processes just go exponential. So code reviews is a really important part of that, as well as QA regression automation. So she'll be discussing automation as well. And Andrea Williams at People Matter, she's the Senior Director of Engineering, and she started out at IBM and was also Benefit Focus as well. And she's passionate about software quality and some of the things that we're going to address today. And then David, he is from PayNearMe, and he's a 20-year veteran in the software industry. David is a very senior software engineer and leads a team of mobile application developers and also back-end developers for PayNearMe. And so he just moved to Charleston, the area as well. And he'll be discussing front-end UI and mobile application development, which he has a lot of experience in. So we have a really great panel today, so I'm excited. So you guys, hit them hard. So thank you. And then me, the moderator. I'm really involved with Code Camp. I love what the Corridor is doing for the community. We try to teach this stuff. I started my company, Open Source Systems, because I believe in open source. I see the power of nowadays, really nobody has a technical advantage because everything is being open source. People are leveraging open source in production for large enterprise systems, and we can teach this stuff at Code Camp. So I love teaching it. And okay, so we want to start out with an infographic here. Okay, a lot of people have seen this, but maybe some haven't. So this It makes me laugh every time because this is literally the software process, okay? And I've done a lot for the federal government, and it is like this every time. So the customer explains, you want to build a swing. So the customer explains it, and they explain it real complicated. And you got multi-levels of swings, and it's got to be this way and that way. And the project leader understood it completely wrong. And then the analyst designed it kind of weird and wonky. The programmer wrote it kind of sloppy. The business consultant described it amazing. It's a big comfy chair. How the project was documented. Let's see. Oh yeah, what operations installed? Kind of halfway. How the customer was billed. How it was supported. And then what the customer really needed was a tire swing. So we wanted to introduce this infographic because it does add a little bit of humor. I mean, it's dead on with what this process looks like, and that's why we address unit testing and code testing is to essentially alleviate some of the burdens that software development can introduce, and the costs. I mean, a lot of times people will ask me, well, how much does such and such cost to build such and such? And really the answer is software can cost as much or as little as you want it to. The government is notorious for spending hundreds of millions of dollars on software programs, whereas you have Kickstarter campaigns that are creating software platforms that are supporting millions of users for $100,000. So it really varies. Okay, so today's discussion, what we're going to be doing is we're going to be talking about what code testing is. We're going to discuss why do we even want to test it, and also what are the specific types of tests. How do you address testing? When you say testing, what are we testing exactly, and how do we test? So I guess with that, we'll go ahead and just start off with the panel then. I guess, David, would you want to maybe start us off talking about what is code testing and why we do it?
What is code testing? I guess I'm much more interested in the why, but what is, when I think of what is code testing, I think computer science, and when I think computer science, I think just like any other science. If you're going to collect data, if you're going to come up with a hypothesis, collect data, and then prove that hypothesis, you need to be able to show your work. And code testing to me is showing your work. If you're going to produce some software, you need to show that it works, and you have to have tests to prove that. So to me, testing is proof.
Okay. Do you guys agree with what?
It is. Yeah. I think more and more the people who are actually coding, typically the software engineer coding the product, is separated from test. And I think that's changing more and more. So a way to prove that what you coded meets the acceptance criteria, and hopefully you have some from a product owner who's on the team, and you don't have that first infographic going on. It's a whole team mentality, right? Working together. Then they can write the tests for meeting the acceptance criteria, pass it along to quality assurance. QA can morph it, can expand it for all the various tests that we do. And the end, really the result and the why is all about our customers, right? If you're spending time building quality code, it's worth it. We know the expense down the road of a bug, right? It's a lot less if you're actually fixing it right when it's introduced and you're catching it right then. Ultimately, we want to prevent bugs. We want high code quality. So code quality is huge, but product quality is huge too. If you are spending all your time in production, you're not delivering more and better stuff for your customers. So really we're trying to push all of that quality upstream as much as possible.
I would agree with that. And also the pushing it up as far as, or as early as possible in the process is really important to me. And we actually have our QA analysts sit in on the early on planning process, meeting with the product owners, so they can already start formulating, how am I going to test this new thing? And they can ask questions because, there's a tendency to think about a happy path, when you're initially figuring out this wonderful design for something. And the QA analyst is thinking about, how can I break this? So that's an important part of it too, having them involved early on.
Interesting. So do you think it would be fair to say we could sum up code testing is essentially testing your software against some sort of certain criteria that was established by stakeholders and product owners? Is that?
I think that's part of it. I mean, I could test something without having any of that, but am I really testing what the customer wants and what the product owner understands the customer wants? You know, if proactively, if you're not in production yet and you're just getting started, you have to try. And you're going to cover a lot of the product, but then down the road you get the instrumentation and the analytics to prove if you're right or not. If you're not, that's okay. You're not going to get rid of the internal test that's testing what the product can do. But you want to make sure you're focused on what the customer's usage actually is.
So I guess maybe that's a good segue, or does kind of address why do we test the code, right? So we essentially test the code to ensure that we're abiding by requirements of stakeholders. Would you say, right? So do you find that customers are willing to put in the extra costs in order to introduce this quality assurance step and process?
They're learning they have to.
Yeah.
Well, it's expensive if they don't,
Yeah.
right?
Yeah. So what are the different types of tests? I mean, when we talk about testing software, how do we test it? Is testing just sitting down at the console, banging at the keyboard, and seeing what breaks? I mean, what are the different angles we can take?
It's monkey testing. Sure, that's a way of testing.
Okay.
But we're smarter than that, and we can do better than that.
There's also there are the different standard types that you may hear about of unit testing and functional testing and regression testing and like that. But there's another one too that sometimes gets lost along the way, and that's user testing, especially if you're developing a brand new feature and you come up with a prototype design. It can even just be wireframes, or it could be a working prototype. If you can get that in front of real users so that they're actually just put it in front of them, and what happens? Can they get through a particular task that you're hoping to accomplish with it? And that can do a lot if you can do that early on. You have to get the users to stop what they're doing and do that for you. But if you can get some strategic partners, especially if you're doing a brand new application or feature, then it's really helpful.
Okay.
So I absolutely view the different types of testing as not a set of types of testing, like you're saying, unit test, integration test.
Yeah.
I view it as a process. It is from the get-go as you're sitting with the product managers and the customers and developing the feature from that stage all the way to when it gets to production. So that's all of your iteration going in. So yes, you have unit tests. Yes, you have integration tests. You have functional tests. But you need a process that facilitates the whole group of people, the product managers, the customer, QA, the engineers. They all have to be involved, and they all have to be talking. And there has to be a framework set. There has to be a process set up to set all these things in place. And when you set all these things in place, you get unit tests, and you get integration tests, and you get customer acceptance tests. And so I definitely think of this more of a holistic. What are the types of tests? It's the whole thing. It's the process that you have in place.
Right. Okay. So testing is a process that essentially the development team, as well as the customer, has to establish. I mean, the customer has to have a stake in the in the test process as well, right?
Mm-hmm.
Okay. All right. So I think this is kind of an interesting question here. When we talk about software quality, what does that mean? I mean, what differentiates good software versus bad software? How would you quantify?
It's what the customer's perception is. You know, if there's a metric that's often used, and that's the Net Promoter Score, and really it's a question to the customer of, would you recommend this software to a peer or colleague? You know, and what you want is for your customers to be raving fans. If they leave their current company and go to another company, you want them to say, I want this software. I used it in my last company. I can't live without it. You know, I can't do this work without it. So that would be a Net Promoter Score of 10. You know, they'd be saying, yes, we're raving fans. Well, then they would rate it on a 10-point scale, and the 10 is definitely the highest promoter. So I would say tracking Net Promoter is really important, getting that feedback from your customers, and then going a step further of, okay, here's the rating. Now say, why are you giving that rating? What would it take to make you a 9 or a 10. And it might be performance, which is a big factor in quality. It might be, there's functionality might be light. It's any number of things, but ultimately I think it's in the eye of the customer.
Customers can. Yes. I don't disagree at all.
Can I ask you a question, Jack?
Yes.
So there's a trend toward test-driven development where you write your tests, the engineers write the tests based on the acceptance criteria and then build code against it. And I wondered what you thought of that and if any of you are actually using that process in your work.
We do have, I've talked to our engineers at various points in times of how much they do when and what type of unit testing. And yes, we do have ones that do want to do the test-driven development because then they're, from the get-go, understanding what the requirements are, the acceptance criteria, and then writing the tests that are going to fail initially until they write some code to go with it, but then develop the code based on the tests. And hopefully that way they're covering all the criteria. You still have to make sure the acceptance criteria are right, so that's why it's a process. You have to start at the beginning with your quality, but we do have people using test-driven development.
We do as well.
So how much automated testing, what percentage of testing would you say of your code base when you do a release, how much is automated tested? Are you just focusing your QA people on what's new and doing automated regression testing on the rest, or how does it work?
So we have a lot of products at Blackbaud, and for our legacy products, how much investment do you want to put there versus the new products? For all of our products, we follow an agile methodology. You have to have a methodology, and we are not trying our hardest not to create any more tech debt, and that includes automation, right? If you haven't been automating, you have a lot of tech debt. So for the newer products, or for any work we do, it is automate as you go. For the older products, they might have less code coverage with automation, and that might be okay. What we've done for our legacy stuff, because we're automating as we go in our sprints, is used outsourcing highly to help with some of that legacy stuff. But in terms of code coverage and the right percentage, I think for a new product, brand new, and for going forward, the ideal would be 80 to 85%. I mean, that's a guideline where you are getting a lot of coverage, but you are not wasting your time on those like super edge cases where the errors are outside of what the customers actually do.
Good, thank you.
So I guess kind of talking about test automation, test-driven development, and you had mentioned before about the different types of tests you can run. So I think we might have some people here who are new to software or maybe are not too familiar with what all these tests mean. So do you think maybe we might be able to cover what y'all's experience is, the different, like, what is a unit test? What is a functional test? And isn't a test, right? I mean, what's the difference between these and how do we address them? And what do they address with the software?
Sure. I mean, I'll take one.
Sure.
So with the unit testing, I mean, if you think about it, the software developer sits down to write code, and they're writing an isolated piece. It could just be a method, or it could be a small application or a modular component. So they're trying to make sure that piece of software is that ideally, if you get 100% coverage, that you've tested all the lines of code and logic that are executed. But at some point, you're going to migrate to interfacing with other pieces of software that your company has written or your team has written, unless you're in a vacuum. And at that point, that can be called integration testing, where you're testing that what comes out of your piece of code into someone else's piece of code. That you don't break, their code doesn't blow up, that you're sending the right type of data they're expecting, and vice versa if they return something back to you, that you can handle it, whatever they return back if you're requesting a piece of data or information. So, but that can go much larger. You could be integrating with completely different systems external to you, third-party systems that you have no control over, using APIs, application programming interfaces, where there's a contract between you and the third party. So you have to test that and make sure that what you're sending back and forth, exchanging with these other systems, works as you expect. Because then it's a black box. You don't necessarily know what's going to happen. So I won't keep talking about every type of test. I'll pass along to the others and let them chime in on some of the other types of testing.
I'm guessing a lot of you are CS grads, and as you went through your program, how much of the curriculum involved testing? In all my programming classes, I took one class where I was required and learned about unit testing. And I hope that's changed. Like, I mean, I'm older, but the unit testing it's got to become the new norm. That where it's not a question of if you do it. It needs to be done. We need to catch these things as soon as possible, right?
Can you
And the
describe what
engineers
unit
need to
testing
do.
is? What is?
It is exactly what you were talking about, where an engineer writes a small piece of code and the unit test covers that. And when you are checking in something, a change to that, you can run that unit test to make sure it hasn't broken. So, and the 80 to 85% applies to unit testing as well, the code coverage.
I
And
go
I
for
bet-
100.
Do you?
Absolutely.
That's great.
And I would add something about unit testing. When its value kicks in is when you're refactoring, right?
Right.
Because you at that point you want to know, can I run the unit test? Is it working now before I make these dramatic changes to it or refactor it? And then afterwards I'll know, if I broke it along the way. So I think refactoring is a key point when you want to,
Mhm.
when having good coverage is most valuable.
Mhm. QA testing and getting into it, I love it. I mean, the types of testing and the different things you can do to cover the product has to be comprehensive. I mean, there is all the compatibility, right? Different browsers, different versions. There is the security. We are PCI compliant. We do OWASP testing. And people say that, but what does that mean? Are you doing the top 10 with OWASP? Are you doing the top 3? And it's always changing. We've used a security vendor to come in and have an independent third party attack it and say, these are the things that I would recommend. I mean, there's static code analysis for that as well. But there's multi-user testing, there's load testing, there's so much you can do, and you have to do all of it. And I think that's kind of the answer. You have to do all of it. Functional test, I'll say that just like the engineer is covering a small piece, QA with a functional test can cover a module, a component, right? And that might be functional area 1, there's functional area 2, and then you write tests. If they integrate, the integration tests cover those. So then if there's refactoring or bug fixes, enhancements, whatnot, to an area in functional area 1, you're going to run those tests, and I hope they're automated, on functional area 1 plus the integration of anything that touches functional area 1. So it's nice to write your automation in that way, to organize it that way.
Could you ever come up to a situation where unit tests may pass, but like let's say an integration or functional test could fail against the same code? What would be an example, I guess, of just to kind of show and demonstrate that these are actually two separate tests where you can have in one domain that all your tests may pass, but in some sort of other domain they actually fail? What might cause something like that to occur?
Can I take it? Even the question suggests comparing an apple to an orange.
Right.
Because in the unit test is an atomic test against a small piece of code. So if you have a car object and you had a method to turn on the lights, you have a test to prove that you can turn on the lights. You have a test to prove that you can turn off the lights, right? So an atomic piece of code for a very small thing, a very small task, right? Whereas you can build up thousands of these unit tests. You will build up thousands of these unit tests. At Painter Me, we're a financial services company, so we have to have proof that our stuff works, right? We are SHAE 16 compliant and getting PCI compliance, right? And if you're going to have these levels of compliance, you have to have the proof. And so the unit tests, the previous slide said, what is good software, what is bad software? I don't know what bad software is, but I know it when I see it, right? It's that type of thing. Well, you know what good software is because you have the test there to show it. So unit tests for me are the sweet spot. And so yeah, you can have thousands of these unit tests run, but then they got to go work in a whole environment where they may hit other systems, they may hit outside systems. And so absolutely, you can have your thing work in isolation, but it also has to work against the greater environment, right? So that's the apples to oranges comparison. And that's why you have a difference between a unit test and, say, an integration test. Because, yes, prove your work, prove it down to the individual lines and individual methods, and then prove that it can work in the system as well. So we have unit tests, we have integration tests.
I'd like to jump off something Sarah said about load testing, because the performance testing is really important, and also doing it at the right time in the process. One thing about that is ensuring that you could load a bunch of dummy data into your system. You could write a little program that just fills your database up with wonderful dummy data. But if you're not really looking at the profile of the users that are going to be using the system in production, then you could still just completely miss the boat, because you could end up in a situation where you have tons of one kind of data, let's say, all this information about applicants, but employees you didn't maybe load up as much, and instead you have clients that have a lot of existing employees. So there are things like that where you look at the profile of the data that will be in production for your clients, your customers, your end users, and the types of users that you have. And one of the things, you can call that a user persona. So if you have a profile defined of the type of person that's going to be using the system, whether they're a person that's on a shop floor or a manager sitting at a desk in an office, how they use the system, then that can help you a lot. It can help you with load testing to have the right profile of data, and then it can help you with functional testing to have the right kind of steps that you take through the software to match what a typical user of a certain type is going to do.
And you'd also mentioned, I guess one of the differences between unit tests and integration tests is that unit tests are done in isolation, where integration tests, what that code does once you start integrating it with other external services. So what would you do if you're trying to run unit tests that are supposed to integrate with external services, but you want to run them as unit tests? Because you're really not supposed to test against the external services if they're done in isolation, right? So what would you do to, I guess, approach that?
So go ahead.
You go ahead.
I just finished talking.
There's unit tests for the integration code as well. But, like you were talking about an example, if you, I work some in the K-12 school software. So if you add a student here with a certain status, maybe it should show up. Like, here's an applicant, it should show up in the applicant system. Well, add a student might work, and you add the student with that status, it's not showing up in the other system. So there's your example of the unit test passes, the integration test fails. But there should also be, for the code that makes it show up, there's unit tests for that too. It's looking at, whatever the add student is when that happens and the student saves, I think there's a unit test for that. Does that make sense?
One thing you can do too is to create stub code or test harnesses that, stub code could be a bit smaller while you're testing that more isolated piece of code. So it's something that will interact with your piece of code, but you know what it's going to give you back. So you're cheating a little bit. It's not perfect, but at least you know that for the expected data that's going to be exchanged, that you're going to be able to handle it if you pass your tests for that, using that stub code. A test harness could be a lot more complicated. A test harness could try to mimic a third-party piece of software where there are a lot of interface points and different methods being called. But the nice part is that at least you ideally know that you're at all those different points of exchange, at least what you know about them, for that third party that your tests are going to pass by doing that.
So you essentially, if you're trying to do unit tests and run these in isolation, you essentially mock those external services so that your test harnesses return data as if those external services were functioning correctly, right? As expected.
Right.
Okay.
Stubs and mocks.
Stubs and mocks.
Yeah.
Well, okay, cool. So I guess a couple other talking points about code quality is metrics. What are some ways that you all use to quantify the quality of your code? In terms, you can go to your customer and say, we are at X and we need to get to Y. What are some ways to do that?
well, you can do, I mean, one of the things you can do from determining are we where we need to be from a software quality standpoint is come up with a prioritization of an issue. You know, is an issue a priority 1, 2, 3, 4. You can use terminology like blocker and critical and medium, you know, so you can go to different levels. And then you can have criteria where you say we're not going to release if we have any blocking bugs or any you know, critical or high bugs. Or maybe you say, well, we can have a few high bugs. So there are things like that to know, is your software good or where it needs to be. You could say, I want to have no bugs, which if you're looking at agile development and Scrum process, you could actually say, when I'm developing a new feature, a piece of functionality, I don't want any bugs out of, as far as I know. You know, so you can test and come out of that and say, I'm not releasing this until there are no bugs, or I'm not releasing it, yes, until there are no bugs. So that way, now there still may be bugs hidden in there, right? Because you know, with all the testing you can do, somebody's going to do something. You're going, well, I never imagined anybody would do that. But at least when you release, you can feel good that okay, there are no bugs.
Ooh, it's kind of interesting. Would you guys say that, I guess, because a lot of the updates are automated now, you know, with your iPhones, for example, you really don't even have to update anymore. They just download automatically. That you see a lot of companies actually using their user base as their testers nowadays. So beta, right, is a big deal now. Just releases beta and see what happens, right? So very cool, yeah.
I prefer not to do that, but yeah. Because then you have the other cost, because if your software is going out there to thousands and thousands of users, and you have a support team that gets phone calls, you know, then you start getting the cost to maintain the product, where your support team's on the phone all the time trying to explain if there's a workaround. So we'd rather not do that, the beta tests on our users.
So it's my boss says to me quite often, if you're not measuring, you don't know. So you have to have metrics in place to measure your quality. And I can tell you that you need to continually challenge yourself to make sure that you have the right metrics. So metrics change. You know, there's because things still happen in production. I'm sure that you guys still see bugs in production, right? So hey, good metric, bugs found in production, right? And then so you say, well, why are we still finding bugs in production? What other metric can we look at to introduce while we find that, right? And so you have to continually ask yourself, what metric I need to look at now? And so have a set of metrics, whether that's your service level agreement. You know, is my SLA up to par? Yes, no. You know, good metric. Does my code have coverage? Yes, no. How much? Does my code have coverage for the positive case and the negative case? You know, how do you know? And you know, you can, bugs found in production, I think, is a great one. Bugs found in QA versus development. So can we lower that number? And so can you develop a set of metrics, and can you continually try to improve those metrics? And if you're not doing those things, if you're not measuring, you don't know if you're making the improvements. So.
And on the bugs found in production, one of the things we've set as a goal or trying to do is, it's not just this bug was found in production, it's how many issues have been reported by the client per number of users. You could look at something like that, for example. So if you're finding X number of bugs per 100 users, then how do you bring that number down? So you could set a goal that by this date I'm going to go from this X to Y. You know, and reduce that. And things you can do is look at like root cause analysis. What caused the bug? Because that's what you want to do. As you say, you don't want to say, oh, here's our report. We have we had 10 bugs reported. Okay, why? What caused it? And then what can we do? Can we change something upstream in the process of the requirements definition? Maybe there's something we missed about. Oh, okay, let's have performance be a part of the conditions of acceptance. That this meets the criteria of the requirement, is that it has to, all the page loads have to be 1.5 seconds or something like that. You know, so.
And really, as you establish those release criteria or quality criteria, You don't ever move away from them. That's the new normal. You just add to them and you get better and better. So if, just like you said, if it's still too high, well, what else can we try? What else can we add to our quality processes? And there's always more you can be doing.
And if you think you got them all today, they're going to change tomorrow. So you have to be introspective, right? And that's the hard part. Nobody wants to be introspective, especially when you're evaluating your own work or your team's work, right? That's the hard part. But look, there's always going to be another metric. There's always room for improvement. And so, challenge yourself to dig and find those areas for improvement.
Another, just one more thing on that, sorry, that I would add too is it's important to, when I talked about user testing, it's also important to make sure that the engineers and the quality assurance analysts get an opportunity to see how the end users are using the software once you have something out there. So I've been on many sessions where we were having an issue and maybe we couldn't reproduce it or it was strange. And so we get actually on a go-to meeting with the client if they're willing to do that with you. And then, the engineer's eyes will be like, oh, okay, I see, So that's very valuable too if you can, don't keep everybody locked away, in a room throwing requirements over the wall, one of those analogies, but actually give them an opportunity from time to time to actually see what the customer does and how they do it.
Yeah,
learn from that.
Yeah. And there has to be good communication. So communication is king.
Yeah.
And also, like David was saying, nobody likes to call their baby ugly. So, introspection is important as well.
Two things we didn't mention that I think we should throw out there. You should have metrics for performance and for security.
Mm.
Have a security harness on your code and test your performance, and those are some key metrics.
And I also want to touch on technical debt. If we can maybe just briefly describe what that is, and as a metric of the quality of your development process, right? So what is that?
It's everything you didn't do right. If you were to go back and start all over and make it clean, that you would want to redo. So it might be the bugs introduced that you haven't fixed yet. It's the automation you haven't written, the test cases you haven't documented. It's the way you wrote that code that's not quite right and you want to refactor it. It's the lack of unit tests. It's everything that isn't up to quality.
And the world never stops. So, wouldn't it be nice? We're a Rails shop, and we just got our stuff last year moved to Rails 3.2. Well, now Rails 4 is out, and if you don't move, if you don't keep up with the right versions, you fall behind, and new stuff becomes antiquated and unmaintainable. So the world keeps moving, and you got to move with it, and that's your technical debt.
And so I guess what time is it? We've got about 20 minutes. I wanted to leave about the last 8 to 10 minutes. One thing at Code Camp I always do is during the courses, I always tell my students, don't believe me. If I'm sitting here and I'm teaching you C++ and I'm telling you that a struct is supposed to be 32 bits in length or whatever, don't believe me, make me show you. So I wanted to take about 8 or 10 minutes just to actually demonstrate from scratch, building a project, writing a unit test, and doing code coverage so that you guys can actually get a visual of what we're talking about here. I think that's really helpful for people, especially who may be new to this. Interesting topic that was actually brought up before, test-driven development. And what is that? And I've noticed that kind of seems to be can get heated because people get really passionate about the process, right? And it's almost like kind of a religion for them where they've got it figured out and everybody else needs to follow that standard, right? What is test-driven development, and is it something that people should do, or is it something that you guys incorporate in your processes?
It is writing the test before you write any of the product code. So it's failing until you write the product code to make it pass. And we do it at various teams, try it. I think it's one methodology, and I think people should always be trying new things. We are an agile shop, and we really believe in every sprint trying something new, and if something's not working, you tweak it. You might go back to saying, no, this doesn't work at all. Just like, it might be paired programming. It might be like whatever it is, there's things you want to try. I think test-driven development, when people try it and give it enough of a chance, I think they tend to stick with it. So I think it's becoming a best practice.
Yeah, and we have, go ahead.
Yeah, we have a lot of experience with this, and I will tell you that we insist on on test-driven development, behavior-driven development, whatever you want to call it. At the end of the day, it is do as I say, not as I do. I'm more like a cowboy coder. I like to sit down and think through some code first, and so not necessarily always doing a test-driven development. That's how I like to work. When we do a lot of pairing, and pairing is a great way to do this too. And I don't see a lot of that as really test-driven development. But at the end of that session, we always go back and write our tests. So we don't compromise. At the end of the day, we don't compromise on unit tests at all. We shoot for 100% test coverage. I will tell you that we have over 40,000 tests, and we have 95% coverage overall. The projects on my team, that's company-wide. On my team, we shoot for 100%, and we maintain 100%. And just one thing, the thing is, if you hit 100%, right, and then anybody checks anything in and that number goes down, there's a level of shame that just comes with it, and they will go back and fix it. So if you let it slip to 98, if you let it slip to 96, then that level of shame goes down, right? Well, it was from 96 to 95, so it's not that bad. But that 100%, if you shoot for that 100%, maintain 100%. Go ahead.
How do you measure that percentage?
So we have code coverage tools will do that for you,
Mm-hmm.
and you run your suite. And at the end of when the suite completes, it'll produce a report, and you get that report, and that report gets sent out if you want it sent out, or you just go and look, and these code coverage tools are awesome because they will not only show you the class, but the line that was missed, and then you can go back and write a test for that. But
is that in-house for you, or is that third party?
That's in-house, yeah.
Okay.
Yeah. We're Ruby, so we use simple code.
You developed that code coverage tool?
No, in almost any language, there's a plug-in, a gem, whatever you want to call it. But the misleading metric there, though, is coverage, right? You can have 100% coverage, but that may have just hit lines of code. And it may just be the go right case. And so we strongly encourage everybody to have 110%, right? You have to have the go wrong case. You have to have the go right case. You have to go right. Your expectations should be there to fulfill everything that can happen, and it's the developer's responsibility to make sure that they get that covered.
So I'm going to stir the pot a little bit here. We had the GitHub guys in. I had the CTO from GitHub, and I had to have lunch with him and talk to him. I said, "Tell me about your QA team." And he said to me, "What QA team?" Mm-hmm. And there's some trends. He said, when we don't have QA teams, our developers understand that their code's going all the way to production, and they hold themselves accountable to knowing that's not going to impact our organization. And I've seen this where the build was just too long, throw it over the fence, and all that. Which y'all's, that's a pretty scary thought. No QA team. What's your all's thought on pushing that back into the engineering? I always said my best engineers were my best quality assurance people. Yeah. That's a touchy topic, but I'd be interested in y'all's thoughts on that.
I think that it is sometimes we in QA take what we get, and we need to be stronger than that and the dev team can be sloppy just knowing we're going to catch things. So we need to change that mentality, but it doesn't mean you get rid of QA. Of course, we need to be one team, and the engineers need to be really stepping it up at all times. So it shouldn't take getting rid of QA for that to happen. If dev is doing an awesome job, it does reduce the need of QA. QA is there to find the bugs, and as long as we're finding them, we should keep working, right? So the reason that you have that QA team is because they're finding bugs that dev missed. If dev is doing that and the customer rate is like super low, that's great. But what tends to happen is that dev doesn't, first of all, they should never be testing their own code, right? And maybe they're getting good at testing each other's, but they're not testing experts unless they're getting the training and they know all the comprehensive types of testing. And I just worry if that's really happening because it is its own discipline. And even if it's a small team, which I think is ideal, I think there's a small team writing, doing the test design, which is huge. You have to automate and write the right tests. So if they can do that, that's awesome. But I think that would be the exception, not a good practice, in my opinion.
So I see it. It depends. That's my answer, and it depends on what your product is, right? And so in Silicon Valley, you see a lot of this because there's a lot of venture capital, and there's a lot of. I mean, they're developing an app for everything, right? And whether it makes sense or not. So if you're developing an app to like face swap kittens, can you go without QA? Awesome, right? If you're moving people's money in financial services, are you thinking about cutting QA? No, I mean you're thinking about adding QA, right? And I'd add that it also goes to your process, right? There absolutely development methodologies, mature software development processes where you can go without QA, and you just have the pieces in place where you have the typical scenarios. You pair program, and everything is pair programmed. And then it's code reviewed by a separate set of people, and then it's tested and run by the team, and then it goes to production. And so I mean that lots of people do it. It's definitely a way to develop, and especially if you're developing fast and developing cheaply. On the other hand, if you're doing financial services, medical, anything with privacy, you can. So.
I'm on the it depends bandwagon as well. I can see where there would be some situations where it just makes sense, and that is also a case where if you're not having QA come back after you, is having that 100% code coverage is.
And it's not just the 100% code coverage; it's the 100% and the code review. Yeah, so in your slide, you have to insist on code coverage, and you have to insist on code review. And code reviews, you're looking for performance issues, security issues, functionality. Does it work? And then everybody's favorite, the style. Is this within the style of the company? And and this is where you get religious and dogmatic. And if you're not having interesting conversations in your groups about the style of the code, then you're not doing code reviews, right?
And the maintainability.
And the maintainability.
Cool. Great. So I think we're about 10 minutes till we end this. QA talking points, automation of build verification. Today I did want to provide a demonstration of Jenkins and automating the build process because, David had mentioned before, there are tools that provide all this stuff, whether it's code coverage, build automation, integration testing, and actually quantifying technical debt, quantifying code styles. There's tools that will analyze your code and look, is my style correct? Is it best practices? There's just so much in terms of what you can do to automate your testing processes. I promised Caroline I would have everything working today, but my server went down. So unfortunately, I can't demonstrate, but if you go look at Jenkins. So what we are going to do today is I did want to do a demonstration because I want you guys to leave here with a little bit of a solid view of what exactly that we're talking about. So I'm going to get really brave, and I'm going to go ahead and try to actually demonstrate this for you guys in terms of code coverage and testing stuff. Is that cool with everybody? Okay, all right. I think it would probably be a good way to end this. As a developer, we're going to be using tools like this. So this is a tool called Eclipse. It's an integrated development environment, and we use it. It's used pretty extensively out in the community, although there's a lot of other IDEs that do exactly what Eclipse does as well, but this is what we're going to just demonstrate today. And what you can do is, I'm going to go ahead and do Java. Java is a pretty, it's a pretty standard programming language. So what I'm going to do is I'm going to create a project called a Maven project. And so what a Maven project does is Maven is a Java tool that allows you to essentially automate your processes. So whether it's a build or your testing processes, Maven will allow you to automate that. So we're going to go ahead and just create a simple Maven project here. Was it? There we go. Create a simple Maven project. And say next, and say just simple and simple. And we can finish this. And so there's a lot of other languages that provide these types of builds. And I guess, David, what would be an example of maybe a Ruby build framework?
It's built into the Ruby on Rails framework, and whenever you sub out a project, you can choose your test framework. RSpec is by far the most popular, and so RSpec.
Okay. Yeah. So Rails, I guess, would be a framework that would also offer a lot of these capabilities. So what we're going to do is we're going to create a simple calculator. And so what I'm going to do is I'm just going to say I'm going to create a simple method called plug static int add, where you just take two numbers. And you essentially add them together. So this is some code that I wrote that's supposed to perform a function of a calculator, which is adding two numbers together. So if I want to test and essentially verifies that this works, I could essentially give it a 1 and give it a 2, make sure that it returns a 3, give it a 4, give it a 5, make sure it returns a 9. You know, I could do that. Or I could write a unit test that essentially automates this. So within Maven, you'll see here that we have a special place that we put our unit test. So I'm just going to say new, what is it, JUnit test case. I'm going to say test math. Say OK. And then so for our test here, you can say that we're going to say test add. I'm just going to say assert true.
Weren't you supposed to write the test first?
No, that is a test right there. Yes, I was. Good point. Yeah, thank you. I was supposed to write the test first, so bad chat. But so we'll go ahead and write the test afterwards. Exactly. Well, we can actually demonstrate that as well. So okay, computer. There we go. Okay. So this is what a unit test looks like. So essentially, what we're doing is we're trying to assert that addition method that I created actually adds two numbers together. Right, so it's a very simple case. So we'll say 3, and then here I'll say math.add, and then I'll just pass it a 1 and a 2. And I don't know what is going on with my computer today, but okay, I'm too fast for it. Too fast for my computer.
Search.
I had this working this morning. So so what we should be able to do is, it doesn't like that, does it? Is we want to assert essentially that 1 plus 2 equals 3. And then what we can do is we can right click
Do you want
on
to say 3 equals math.add?
assert equals, I'm sorry. You're right.
God, these pair programmers.
Thank you. Okay, so I want to assert that they're not true. I want to assert that they're equal. So what I'm doing is I'm using now JUnit, which is a unit testing framework for Java. And as David said, there's a lot of different unit testing frameworks for all the different languages there. I'm using JUnit to essentially assert that my addition function actually works. So this would be an example of a unit test. So you can right click here, and we can say run as. Oh my goodness, what is going on with my Mac today? I'm not sure. Okay. And for anybody that's ever done a demonstration real time, this is how it goes every single time. Okay, now Eclipse should, so it's launching the unit test. So Eclipse should open up a little thing. Okay. I'm sorry. Okay, well.
You need to import.
Yeah, it should be important. So what essentially Eclipse will do on a good day is Eclipse will run the unit test, and then it will demonstrate in this window here all of your unit tests that are passing or failing. So as David had mentioned, in a company like TaylorMade, you're going to literally have tens of thousands of unit tests that are run against your suite of software. And so it's important to be able to automate this process so that as your developers are checking stuff in, you can continuously monitor their code to make sure that it functions as it should from a modular perspective. And then from a code coverage perspective, if I were to go into this math function and now make my calculator subtract, and I don't, so essentially right now I'm essentially 100% covered because I have one method that adds and I test that addition, right? But if I were to make my calculator subtract, like this, if I were to do a subtraction method, now I would be 50% covered because now I only have one unit test that's only testing one of my two methods. So that's an example of code coverage, and you can run tools that will automate this and give you metrics on that in pretty much any language.
But there's also an open source tool, Sonar, that we use as well. And I mean, we had an intern for a month play around with it and write a little bit of code to make it give us what we needed.
And
I think-
go ahead.
I think so. There are some static code analysis tools out there that do a really good job of checking all sorts of maintainability and extensibility of your code. But you have to be real careful when it comes to JUnits. Some of them will count just a simple action of accessing your classes and your methods as code coverage. Will count you at 100%. And it's a constant fight that I have with a lot of developers is that they'll create out their unit tests, never actually assert anything, and call it complete code coverage.
Oh.
And that becomes an absolute nightmare to go back when you have 300,000-400,000 lines of code on a federal project and they don't want to go back and do any tech debt. But when you're choosing your static code analysis tool, make sure that it's a tool that does validate if there's an assertion in there or some sort of configuration that you can put that in, because that can be a real big pain in the ass.
So there's some static tools that will actually detect line-by-line coverage in a lot of languages, which you could check to make sure you have 100% coverage of every line. You're hitting every conditional, and
Absolutely.
worth looking into.
But we want that not just for unit testing, we want that for our QA automation as well.
It's tricky.
I had
It's tricky.
a question about testing environments. How well can you tell it's going to work in production? For functional testing, you use fixture data. For maybe quality testing, you might have a staging environment, but it's very difficult to test all possibilities of configuration and data. So how do you best? Have you guys ever had any issues where things weren't caught in fixture data or in staging? And
No.
how do you best try to mitigate that from happening?
I can speak. I'm sure that you guys have your own methods. As you march towards production, you march closer and closer towards the edge, right? And so we have environments set up to most closely mimic production as possible, right? So we have test prod, we have patch prod, we have everything that you can think of around prod. And what we do is we take dumps of production data and we load that into those environments. The network environment, the hardware environment, everything is mimicked as closely as possible. And so, yes, we do our from the unit test to the integration test to the smoke tests and we run all of those tests on each environment before it marches to production. And then still, you'll see something will pop up where a private network IP configuration isn't picking up addresses coming in, and it caused something to pull up, right? And so it still happens.
And for compatibility, there's also, you can run your automation to work on all the browsers, all supported browsers, right? So it's not manually going in and doing all of it. So the tools are getting better to help with that, but yeah, still challenging.
One of the things that we added to our battery of tests that we put the software through before we release it. And we have the different environments. We have like a QA development environment, a production-like environment, an even more production-like environment. So we get closer and closer to releasing. But one of the things we do is in that environment that is the most like production, before we release a significant update would be dry run testing, as we call it, and we actually get not our developers, not our QA, but other people, stakeholders, to actually come and try out, just kick the tires, and just one of the people I work with at IBM called it pooching around, just to see with more real data, like production-like data, if they can break things before we release. So that's kind of the last pass, on top of all the other testing that we do.
Could I ask if you scrub your production dumps when you do data dumps?
Depends on what level.
Testing.
So when I said patch prod or test prod, no, those are real data. So they have extremely limited access to whomever can do anything, and then firewalls are set up so nothing can leak out. When that data, you do need data to be able to come in to develop an environment, and we have limited cases where you can ask and be audited for that type of access. But mainly on a developer environment, it's all seed data. It's all canned factory data.
Or we'll take customer data and scrub it in such a way that it's not recognizable, but it still looks real world.
I wonder if you guys can talk a little bit about the perceived value, particularly in unit testing, and to a lesser extent the integration testing, your statically typed language versus your dynamically typed language projects.
Yeah, I don't. So I'm a Ruby guy, right? I have a long background in Java, but I don't really care about dynamically or statically typed languages. I mean, to me, when was the last time you made a mistake with static or dynamically
Well, I mean, I
typed?
haven't touched statically typed languages in years.
Yeah, okay.
I'm just curious. When I was writing statically typed code, testing wasn't even really a thing.
Me
yet.
too. Yeah.
So I don't really know how it's perceived over there. I've been doing Ruby and JavaScript for years, so.
Yeah. I don't think it's any different. A unit test is a unit test is a unit test. Have a go right case, have a go wrong case, and design your code. To me, it's all about the architecture of the code, right? Have your methods be atomic and as small as possible. Chad's case of A plus B, add and subtract, right? One line. You can test that one line. You can test that one line. When you have a more, your next method is public algorithm, right? And it's going to do addition and subtraction, and so then you're going to have a method for algorithm, and it's going to be able to test this, but you have the confidence that add worked, and you have the confidence that subtract worked. So to me, it's just if you have atomic methods, then you can have atomic tests. You get the coverage, and it's all about confidence, right?
Time for one more question, if there's anything else.
I have one software engineer. How I'm supposed to tell my project manager that I'm 3 days late because I've been writing unit tests? Or better question is, how do we estimate these things?
So I would go back to company culture, and I was talking about the process as a whole. Like seriously, if your product manager is giving you a hard time about writing unit tests, you got the wrong product manager, right? I mean, he doesn't know how to do it. You gotta have a culture where the product manager is almost assuming that you're going to have unit tests in there because he or she wants what he or she's asking for, and that's the proof. So again, if they're not steeped in that culture, if they're, I'd say change it up top.
Yeah, there has to be buy-in up top, and there will be if they understand that in the end you'll actually be faster and it'll cost less.
Mm-hmm.
Customers will be happier. I mean, all of that stuff, right? The reputation will be better, more references, more sales. more time on development versus production, all of it. And it shouldn't be a, can I do this? It should be a, we determine that we're going to set the quality bar really, really high. Stakeholders have to say, yes, we're going to do that. And your estimate's always included. It's not a, here it is with unit test, here it is without.
Yeah.
It's just the way you do business.
Yeah, that's where having everyone buy into what the definition of being done means. So if they don't, then yeah, you're going to have that problem.
And when we first started doing it, our software engineers were like, oh, I'm spending, all this time writing unit tests. I'm a coder. I want to, I want to code the product. And then after maybe 3 months, they were like, yeah, we need this. So they'll get there.
It comes quickly, yeah.
All right, thanks to our panelists, David, Sarah, and Nikki. Chad, our next code talk is coming up in October. The topic is yet to be determined. So if you have any creative thoughts or anything you want to shoot my way, please do, and we'll decide next week or two. And next month will be social media and marketing. What are you doing right, wrong, and how to do the best presence you can out there. Thanks for coming.
Thank you.